Hello everyone. Let us continue with our last point, that is change of order. We have already studied one example depend on this point. Let us see now next example. Example number 2, the double integration 0 to 3 x square to 9 x cube e raised to y cube dx dy. Now first let I is equal to this integration as it is. Inner integrations is with respect to obviously limits is in x, that's why inner integration is with respect to y, and in this case y variable limit has variable limit, okay, and x outer limit are constant. Okay, now we have to change this order, means we have to find out the y variable limits as constant and x variable limits as invariable. One of the limit should be variable. Okay, let us start with the first thing. The region of integration are bounded by the curves. 4 curves are there. Inner integration is with respect to y, that's for y is equal to 9 and y is equal to x square. These are the two variables, two curves, and obviously outer integration is with respect to x is equal to 0 and x is equal to 3. Draw these curves. Our usual notation, x is equal to 0 is y axis, x is equal to 3. Suppose this is y is equal to 9. Okay, then this is the line x is equal to 3. Okay, this is x is equal to 0, this is x is equal to 3, y is equal to 9. Suppose this is y parallel to x axis, y is equal to 9, and accordingly you can draw the sufficient amount of large the given drawing of the given curve, and y is equal to x square is this curve, and obviously if you put y is equal to 9 here, okay, obviously this curve should cross this and this line also. Okay, this is line parallel to x axis, this line is parallel to y axis, and this line is the curve which pass through this line, obviously, because it should cut these two lines. We have to make sure the point of intersection either it is same or different. If you put x is equal to 3 here, okay, or put y is equal to 9, we get 9 is equal to x square, means x is equal to 3. That means this curve should pass through this line, and obviously this curve should cross this line also. That means this line and this curve has same point of intersection. That's it, logically. Okay, now these are the drawing of the curve 1, 2, 3 and this 4, and using this 4 the area under the curve is this shaded area which covers all the 4 curves. Now consider strip parallel to axis and parallel to x axis. These are the two strips. Now what we have to find first, x limits. X limit should be in this case constant variables. Okay, in this example x limits are constant, that's why along this strip you should find the x limit should be in variable. Now this strip moves like this, upper and lower, that's why for x we have to consider lower end of this strip, and it start from x is equal to 0. That's why the strip parallel to x axis, it moves from x is equal to 0 to upper limit x is this strip end to this line, this curve, and this curve equation of curve is x square is equal to y, means x is equal to value of x is root y. Therefore x start from 0 to root y. Okay, one variable we get limit in terms of opposite changing of order, constant, here variable we get. Now here in this original example y limits are variable, one is variable, that's why we have to find out y variables y variable limits in terms of constants only. Now consider the strip parallel to y axis. This strip start from this and it moves like this to this area. Now this curve, this line start from this line, and it start from, we have to find out the lower limit of y, and this line has end this, start from this. That's why at this point lower limit of y becomes 0 0. That means y start from 0 to last this line. This line is y is equal to 9. That's why from the parallel, the strip parallel to y axis, y moves from 0 to 9. Constant limits we get. Okay, this is the only important part of this theory. Now put the limits, we get constant limits outside 0 to 9 and x limit 0 to root y, integrand as it is dx dy. This is the first half, change the order. Now we have to evaluate as it is. Integration, inner integration is with respect to x because limits are in y, and e raised to y cube as it is. X cube integration is x raised to 4 by 4. Take 1 by 4 constant outside, x raised to 4, put limit root y in x, we get, in x we have to put root y raised to 4, means y raised to half raised to 4, means y raised to multiplication of these two y square. Therefore this as it is, upper limit is y raised to square minus lower limit is 0 in x, 0. The limit becomes single integration. Now single integration we have to solve by substitution method. 1 by 4, 0 to 9, y square e raised to y cube dy. Now we know y cube derivative is y square, 3y square. That's why put substitution y cube is equal to t. Take derivative on both sides. 3y square dy is equal to dt. We want y square dy. Therefore y square dy becomes dy by 3. Now find out the limits. Earlier variable is y. Limits are 0 and 9. New variable is t. If you put y is equal to 0 here, we get t is equal to 0. We put y is equal to 9, we get y 9 cube. There is a new variable, upper limit is 7 to 9. Upper limit. Okay. Put all these values in above equation. Above integration, we get I is equal to 1 by 4. Lower limit 0 to 7 to 9. E raised to y cube is t. And dy becomes y square dy becomes dt upon 3. Okay, take 3 outside, we get 1 by 14. E raised to t integration is e raised to t. Lower limit 0 to 7 to 9 becomes upper limit first, e raised to 7 to 9 minus e raised to 0, value is 1. Answer is this. Okay. Okay, now consider next example, third. 0 to infinity, 0 to x e raised to minus x square by y, x square upon y dx dy. Now let I is equal to this. Now area bounded by 4 curves. This is inner integration, limits are in terms of y. Y is equal to 0, y is equal to x. This is small x obviously. And x is equal to 0, x is equal to infinity. Okay, now draw this curve. Y is equal to 0 is x axis. Y is equal to x is the exactly middle line. Y is equal to x, we have already studied in curve tracing. This is y is equal to x. And x is equal to 0 is y axis. And x is equal to infinity. See, x is equal to 1 is this, x is equal to 2 is this, x is equal to 3, 4 up to x is equal to infinity. Infinity we cannot draw, but we have to draw that line. That's why sufficiently on large amount we have to draw this perpendicular line to x axis, that is x is equal to infinity, where on this line each point have x coordinate or x coordinate infinity. Okay, remember this, because infinity we cannot draw, but for just sake of drawing the area, we have to just draw the line wherever possible on this xy plane. Okay, now these are the 4 lines, 1, 2, 3 and 4. Area bounded by this region, obviously this line obviously cut any vertical line. That's why this is the area bounded by this region. Now consider the parallel strips, parallel to x axis, parallel to y axis. Now in this example, x limits are constants. That's why we have to find x limits in terms of variable. Now on this strip parallel to x axis, this horizontal strip, x axis parallel to x axis, this strips moves from, see, x in terms of variable पाहिजे, त्यामुळे x या लाईन पासून स्टार्ट होतोय, राईट. या लाईनला x ची व्हॅल्यू आहे y. त्यामुळे x इज इक्वल टू लोअर लिमिट झालं y टू अप्पर लिमिट इथं एंड होतं आहे आणि इथं अप्पर लिमिट आहे इन्फिनिटी. दॅट्स वाय स्ट्रिप्स एक्स ॲक्सिसचे लिमिट झाले y टू इन्फिनिटी. आता वायचे लिमिट इथं व्हेरिएबल आहे त्यामुळे वायचे लिमिट आपल्याला कॉन्स्टंट फाइंड आउट करायचे. आता वायसाठी उभी स्ट्रिप बघायची वर्टिकल. वर्टिकल जी स्ट्रिप आहे ती स्टार्ट फ्रॉम दिस लाईन y इज इक्वल टू 0 आणि इथं एंड होते या लाईनला आणि ही लाईन इथं एंड होते राईट. अँड ॲट दिस पॉईंट एक्स कॉर्डिनेट इज इन्फिनिटी अँड एक्सची व्हॅल्यू वायची व्हॅल्यू सेम आहे इथं पण पॉईंटला त्यामुळं वायची व्हॅल्यूसुद्धा इन्फिनिटी. दॅट्स वाय ॲट दिस पॉईंट एंड पॉईंट वाय इज इक्वल टू ऑल्सो इन्फिनिटी. Therefore, these are x limit, these are y limits. Put these values in this integration. We get I is equal to 0 to infinity. बाहेर y चे लिमिट constant limit outside, variable limit inside. Remember this. And y to infinity, this integrand as it is dx dy. This is the first step, changing of order. Now we have to solve this integration. Now inner integration obviously with respect to y limit आहे त्यामुळे with respect to x असणार. Now here x स्क्वेअरचं y कॉन्स्टंट आहे इथं इनर इंटिग्रेशनमध्ये. नाव x स्क्वेअरचं लिमिट डेरिव्हेटिव्ह 2x असतं x त्यामुळे हे पूर्ण टीमध्ये टाकायचं. सबस्टिट्यूशन पुट x स्क्वेअर बाय y इज इक्वल टू टी. टेक डेरिव्हेटिव्ह ऑन बोथ साइड with respect to x not y because y is a constant regarding this inner integration. 2x x स्क्वेअरचं इंटिग्रेशन 2x dx y कॉन्स्टंट आहे तसंच राहिला टीचं इंटिग्रेशन dt. ओके. नाव we have to check the limits. Earlier limits are x y to infinity. New variable becomes t. If you put x is equal to y here, t becomes y square by y, that is y. If you put x is equal to infinity, t becomes infinity. Therefore, lower limits become same y to infinity. Put this all values here, we get outer integration as it is. Now inner integration y to infinity as it is. X dx becomes y dt by 2. From this y upon 2 खाली जाणार dt by 2 and e raised to minus as it is x square by y ला आपण t टाकलाय. ओके. dy बाहेरचा as it is. Now this 1 by 2 take outside constant and this integration is with respect to t. That's why y take outside of this inner integration. E raised to minus t so integration e raised to minus t upon minus 1. Rest of the terms as it is. Now take minus outside, we get minus half. This as it is. E raised to minus upper limit infinity t मध्ये minus lower limit y e raised to minus y dy. We know e raised to minus infinity is 0. Remember this because you cannot calculate e raised to minus infinity on calculator. That's why you have to mug up this value. Okay. Now upper limit becomes 0. This minus minus become plus half 0 to infinity y e raised to minus y dy. Single integration we have to solve it using obviously by part rule because this is two function product of two functions. That's why u into v rule you have to apply. U into integration of e raised to minus y here minus derivative of y is 1. Integration of this term again here e raised to minus y integration is e raised to minus y upon minus 1. That minus 1 this minus 1 becomes plus 1. Next term plus 1's derivative 0. That's why by part rule generalized rule stops here. Limits as it is 0 to infinity. Now put the limit in y. We get e raised to minus infinity e raised to minus infinity 0 minus 0 upper limit minus lower limit ला bracket टाका 0 टाकायचं. Here 0 becomes 0. Here becomes minus e raised to 0 as it is. Bracket complete lower limits and square bracket complete of whole integration because half is outside. Now simplifying we get minus minus plus e raised to 0 is 1. Answer is half into 1 that is half. Okay. Now let us see next example. 0 to 1 root x to 1 y square dx dy upon under root y is raised to 4 minus x square. Let I is equal to this. Now area bounded by the curve, 4 curves. These are inner integration are with respect to y. Y is equal to 1, y is equal to root x. Means x square is equal y square is equal to squaring both side y square is equal to x, and here outer are x is equal to 0, x is equal to 1. Okay, draw this curves. X is equal to 0 is this line, x is equal to 1 is this line, suppose. Okay, drawing accordingly. Now y is equal to 1 is same distance you have to take. Y is equal to 1 is this line. Okay, and y square is equal to x क्यों, or x is equal to y square is a this line. Okay, how to draw this curve? By using curve tracing formula, curve tracing method. This is the curve you get, and obviously this curve should pass from this point of intersection, because if you see, put y is equal to 1 here, we get 1 square is equal to and here x is equal to 1, means this point should be 1 1, and 1 1 point satisfied this equation. 1 square is equal to 1. That's why this curve must pass from this point of intersection for this and this is same. Okay, this is the rough drawing of these curves. This is the first, second, third and fourth, and bounded region by these 4 lines, and this curve is this one, shaded curve. Okay, this is drawing of this curve done. Now consider strips parallel to x and y axis. नाव एक्सचे लिमिट्स कॉन्स्टंट्स आहेत, त्यामुळे एक्सचे लिमिट आपल्याला व्हेरिएबलमध्ये शोधायचे आहेत. त्यामुळे एक्सला पॅरल टू एक्स ॲक्सिस स्ट्रिप कन्सिडर करायची. दिस स्ट्रिप स्टार्ट फ्रॉम दिस लाईन, तिथं एक्सची व्हॅल्यू 0 आहे, आणि दिस स्ट्रिप एंड टू दिस कर्व, आणि या कर्वला एक्सची व्हॅल्यू वाय स्क्वेअर आहे, त्यामुळे एक्सचे अप्पर लिमिट झालं वाय स्क्वेअर. ओके, आता कन्सिडर वाय स्ट्रिप पॅरल टू वाय. आता वायचे इथं लिमिट व्हेरिएबल होते, आता वायचे लिमिट कॉन्स्टंट शोधायचे आहेत. तर वाय स्टार्ट फ्रॉम दिस लोअर दिस कर्व, अँड दिस कर्व एंड टू दिस पॉईंट, तिथून स्टार्ट होते इथं एंड होते. त्यामुळं लोअर इथून वरती जायचं आहे लोअरपासून, त्यामुळे इथं वायचे लिमिट आहे 0 कोऑर्डिनेट ओरिजिन, आणि जाते वरती इथंपर्यंत, आणि इथं वायचं व्हॅल्यू आहे 1. That's why these are the variable limits. Changing the order, put these values in the given equation, we get this integration. Okay, now we have to solve this integration. Changing of order we have done. Now in an integration is with respect to x, obviously y square is constant, take outside this integration. Now consider I1, we have to separate solve this integration. Consider I1 is equal to this. Now with respect to x, y square is a constant, y raised to 4 is a constant. That's why for our convenience y raised to 4 put a square constant, because we have one formula 1 upon under root a square minus x square. Okay, now limit you can change. Y square, y raised to 4, if it is a square then y square becomes square, taking square root on both sides it becomes a. नाही केलं तरी चालते, नंतर इथं चेंज केलं तरी चालते, और आधीपत चेंज करून नंतर कॅल्क्युलेशन केलं तरी चालते. इंटू डी एक्स आधीच्या एक्झाम्पलमध्ये आपण चेंज केलेलं नाही आहे, नंतर व्हॅल्यू रिपुट करून आपण चेंज केलेलं आहे. आता या एक्झाम्पलमध्ये आपण डायरेक्टली इथं सगळीकडे चेंज करतो आहे, डझंट मॅटर. इज इक्वल टू, नाव दिस इज द इंटिग्रेशन साइन इनवर्स एक्स अपॉन ए. यू हॅव टू मग अप दिस इंटिग्रेशन फॉर्म्युला. 1 upon under root of a square minus x square dx is sin inverse x upon a. Okay, now here put limit 0 to a. In x, sin inverse a upon a is sin inverse 1 minus sin inverse 0. Sin inverse 0 ची व्हॅल्यू 0 असते. Sin inverse 1 becomes pi by 2. You have to sin inverse 0 is 0. Sin inverse pi inverse 1 is pi by 2. Each and every time write these all formulas so that you can easily understand or easily remember those formulas. Now I1 integration becomes pi by 2. Put this value here. We get equation 1 becomes 0 to 1, y square into pi by 2. Take pi by 2 outside, y square is integration y cube by 3. Put the limits, we get pi by 6 answer for this integration. Okay, now consider this is the homework for you. 0 to pi by 2, x to pi by 2, cos y upon y dx dy. Inner integration is with respect to y, y चे लिमिट इन टर्म्स ऑफ व्हेरिएबल आहेत. ओके, आता इथं काय करायचं आहे, एरिया बाउंडेड बाय द कर्व कसं येणार, हे वायचे असणार, वाय इज इक्वल टू एक्स आणि वाय इज इक्वल टू पाय बाय 2, राईट. इथं एक्स इज इक्वल टू 0 आणि एक्स इज इक्वल टू पाय बाय 2. आता एक्स इज इक्वल टू पाय बाय 2 कसं ड्रॉ करणार, जस्ट टेक पाय बाय 2 ॲज अ सम व्हॅल्यू. ओके. वाय इज इक्वल टू एक्स ऑब्वियसली ही मधली लाईन असणार, वाय इज इक्वल टू एक्स. दिस इज एक्स इज इक्वल टू 0, दुसरी लाईन झाली. वाय इज इक्वल टू एक्स इज इक्वल टू 0, एक्स इज इक्वल टू पाय बाय 2, वाय इज इक्वल टू पाय बाय 2. एक पर्टिक्युलर डिस्टन्स घ्या, इथं एक्स इज इक्वल टू पाय बाय 2, वाय इज इक्वल टू पाय बाय 2. इथं असणार तो पॉईंट, राईट. दिस इज सपोज एक्स वाय इज इक्वल टू पाय बाय 2 line. Okay, and this is obviously x is equal to pi by 2 line. या पॉईंटमधूनच जाणार, बिकॉज वाय इज इक्वल टू एक्स, दोन्ही व्हॅल्यू सेम आहे तिथं, त्यामुळे एक्सची व्हॅल्यू वायची व्हॅल्यू जिथं सेम असते त्या लाईन यामधून जाणार, राईट. आणि एरिया बाउंडेड बाय ऑल दिस कर्व म्हणजे दिस लाईन, ओके, दिस वन, दिस वन, दिस वन, कुठली असणार व्हॅल्यू, ओके, this line, this line, this line and this line, area should be this. Okay, this is for this example. Now consider the strip as it is. He strip parallel to axis, y चे लिमिट इथून काढायचे and x चे लिमिट इथून काढायचे. Use gel pen so that you can easily draw this. Okay, answer for this is 1. This is a homework for you. Now consider second, change of order of the integration. It is just a question